Deepen Pharmaceuticals in association with Higher Secondary Principals Forum.
Hello students, we have already started the coordinate geometry and in that lesson we learnt about the distance formula. It is used to find the distance between the 2 points whose coordinates are given. So let us solve some examples using the distance formula. We have already solved example 1, so now we are solving example 2. So here do the points 3, 2, minus 2, 3 and 2, 3 form a triangle. If so, name the type of a triangle form. So let us draw triangle here. So here the 3 points are given P 3, 2, Q 2, minus 3 and R 2, 3. P 3, 2, Q minus 2, 3 and R 2, 3. So now we have to find whether this forms a triangle. So first we have to find the distance PQ, then QR and then PR. So to find the distance PQ, we have to use the distance formula. So let us apply the distance formula to find the distance PQ, QR and PR, where P 3, 2, Q minus 2, 3 and R 2, 3 are the given points. So here x1 is equals to 3, y1 is equals to 2, x2 is equal to minus 2, y2 is equal to minus 3, x3 is equal to 2, y3 is equal to 3. Therefore, PQ is equals to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is the distance formula to find PQ. So now we will put all the values, that is x2 is equals to minus 2, x1 is equals to 3 the whole square plus y2 is equals to minus 3, y1 is equals to 2. So we will put all the values and then whole square. So now we have to find the value of this minus 2 minus 3, it is equals to minus 5 and minus 3 minus 2 again it is equals to minus 5. So the next step is root of minus 5 square plus minus 5 square, and minus 5 square we know it is 25. So and this is also equals to 25. So 25 plus 25, 25 plus 25, so it is equals to root of 50, which is approximately equal to 7.07. So now we got PQ, which is equals to 7.07. Now we have to find the another side, that is QR. So again we will use the distance formula, that is x2 minus x1 the whole square and y2 minus y1 the whole square. So here x2 is equals to minus 2 minus 2 the whole square, then 3 minus 3 the whole square. So 2 minus 2 it is equals to 4 square and 3 minus 3 it is equal to 6 square. So 4 square plus 6 square it is equals to 16 plus 36. So this is equals to root of 52, which is equal to 7.21 approximately. So now this is 7.07 and this is 7.21. So now the third side which is remaining, that is PR. So now we have to find the PR. So again we are using the distance formula here. This is equals to 2 minus, now this is PR. So 2 minus 3 the whole square plus 3 minus 2 the whole square. So 2 minus 3 it is equals to 1, that is minus 1, and 3 minus 2 is equals to 1. So 1 square minus 1 square plus 1 square. So this is equals to root of 2, which is equals to 1.41. So the third side is equals to 1.41. So now we got all the three sides. Now can you tell that it forms a triangle? What is the condition for the triangle? The sum of the two sides of the triangle should be greater than the third side. So it satisfies that condition. So that's why it forms a triangle. So that is PQ plus QR is equal to 7.07 plus 7.21, that is 7.07 plus 7.21, which is equals to 14.20A, which is greater than this side 1.41. Also QR, that is 7.21 plus PR 1.41, which is equal to 8.62, which is greater than 7.07. So it satisfies that condition that sum of the lengths of the two sides of the triangle is greater than the third side. So that's why PQR is a triangle. There is one more question, that what type of triangle is that? Since the sum of any two sides of this distances is greater than the third distance, therefore the points P, Q and R forms a triangle. Now also PQ square plus PR square is equals to QR square. By the converse of the Pythagoras theorem, we have angle P is equals to 90 degree. So therefore PQR is a right angle triangle. Now let us solve one more example. That is example 3. Find a relation between x and y such that the point x and y is equidistant from the points 7, 1 and 3, 5. So we have to find the relation between x and y such that the point x and y is equidistant from the point 7, 1 and 3, 5. So let P x, y be the equidistance from the point A 7, 1 and B 3, 5. That is, we are given that AP is equals to BP because it is equidistance. So therefore we write equal to sign. So AP is equals to BP. So AP square is equal to BP square. So now AP is equals to, this you have to take x minus 7 and y minus 1. So x minus 7 the whole square plus y minus 1 the whole square is equals to x minus 3 the whole square plus y minus 5 the whole square. Now how to solve this x minus 7 the whole square? We have to use here identity, that is a minus b the whole square is equal to a square minus 2ab plus b square. So this will be equal to x minus 7 the whole square is equals to x square minus 14x plus 49 plus y minus 1 the whole square is equal to y square minus 2y plus 1, which is equal to x minus 3 the whole square is equal to x square minus 6x plus 9 plus y minus 5 the whole square is equal to y square minus 10y plus 25. Now we have to solve this. So we have to bring together all the like terms, that is x square, this x square we have to bring it together, then 14x, then 6x we have to bring together, then y square and this y square we have to bring together, and also the numbers together. So this is equals to x square minus 14x plus 6x plus y square, and this y square will come this side, so it will become minus 2y plus 10y, this is here minus, so it will become plus here, plus 50y, that is 49 plus 1, it is equals to 50, minus 34, that is 25 plus 9 is equals to 34. Since we are taking on this side, it becomes minus 34. So this is equals to, after solving this we will get this minus 14x plus 6x is equal to minus 8x, and minus 2y plus 10y is equals to plus 8y, which is equals to this 50 minus 34, it is equals to 16. So after dividing this by 8 we will get minus x plus y is equal to 2, and this is the required relation. How to find the coordinates of the point which divides the line segment into two parts joining the 2 points in a given ratio. Suppose a telephone company wants to position a relay tower at P between A and B in such a way that the distance of the tower from B is twice its distance from A. If P lies on AB, it will divide AB in the ratio 1:2. So, this is the same situation which we have taken for the distance formula, that is town B is situated 36 km east and 15 km north of the A. Now, here there is point P, that is the telephone company wants to position a relay tower at P between A and B in such a way that the distance of the tower from the B is twice its distance from A, that is 1:2 ratio. If we take A as the origin O and 1 km as one unit on both the axes, the coordinates of the B will be. Now, here the distance is, on this it is 1 km is 1 unit. So, this will be 36 km and this is 50 km. So, the coordinates of the B will be 36, 15. So, now we have to find the coordinates of this point P, that is x, y we have to find. So, let the coordinates P be x, y, draw perpendicular from P to the x axis and also from B to the x axis, which meets at E and this meets at D, and also perpendicular from P to the BE. So, now here we got two triangles, that is triangle OPD and BPC, which are similar, and we know that the ratio of the corresponding parts of the similar triangles are equal. So, therefore, OD upon PC is equal to OP upon PB, that is OD upon PC is equals to OP upon PB. So, now here OD is equals to what? OD is x and PC is equals to what? PC is equals to, this full is 36. So, this will be equal to 36 minus x. So, OD is equals to x and PC is equal to 36 minus x, and OP is equals to 1 and PB is equals to 2. But we know that here PC is equals to DE. So, and we know that DE is equals to 36 minus x. So, we can write OD upon DE is equals to OP upon PB. So, OD is equal to x and DE is equal to 36 minus x and OP is equals to 1 and PB is equals to 2. So, now we have to find the x. So, now we have to do the cross multiplication. So, 2 into x and 1 into 36 minus x. So, this will be equal to 2x is equal to 36 minus x. So, 3x, we are taking this x on this side. So, it will be 3x is equal to 36. So, x is equals to 12. So, now we got the x coordinate of the P, that is equals to 12. Now, we have to find the y coordinate of the P. So, by using the similarity, again PD is equals to PD upon BC is equals to OP upon PB. So, now here PD is equals to y and BC is equals to 15 minus y, and OP is equals to 1 and PB is equals to 2. So, again cross multiplication, because we want to find the value of the y. So, after cross multiplying we get 2 into y is 2y and 1 into 15 minus y is equals to 15 minus y. So, now we have to take this y on this side. So, it will become 3y is equals to 15. So, y, after dividing this we get y is equals to 5. So, now we got both the points, that is x coordinate and y coordinate. X coordinate is 12 and y coordinate is 5. So, therefore, coordinates of P are 12, 5. So, now we got the coordinates of this point which divides this line segment into 2 points, joining the 2 points in a given ratio, that is the ratio is 1:2. 2. So now we have to use this understanding which we have developed through this example to obtain the general formula, that is the section formula. So here we have the 3 points A x1 comma y1, P x comma y and B x2 comma y2. So now here also we have to find the coordinates of P, that is x comma y. So here the ratio is M1 and M2, M1 is to M2. So that is PA and PB, PA is equals to M1 and PB is equals to M2. So PA upon PB is equals to M1 upon M2. So now here we have to draw the perpendicular from A to the x-axis, from P to the x-axis and from B to the x-axis, which meets at R, S and T respectively. And also we have to draw AQ and PC parallel to the x-axis. So now again we got here two triangles, triangle PAQ and BPC, which are similar triangles. So again we have to use that same property, that ratio of the corresponding sides of the similar triangles are equal. So then by A similarity criterion, triangle PAQ is similar to triangle BPC. Therefore, PA upon BP is equals to AQ upon PC, which is equals to PQ upon BC. So here first we have to find, we know PA is equals to M1 and BP is equals to M2. So now we have to know what is AQ. So AQ is equals to what? AQ is equals to RS, which is equals to OS minus OR. So that's why AQ is equals to RS, which is equals to OS minus OR, and OS is equals to X and OR is equals to X1. So it is equals to X minus X1, and PC is equals to ST, which is equals to OT minus OS, and OT is equals to X2 and OS is equals to X. So it is X2 minus X. PQ is equal to PS minus QS, PS minus, which is equal to QS equal to AR. So PS minus AR, which is equals to Y minus Y1. And BC is equals to BT minus CT, and BT is equals to, this is Y2, and CT is equals to PS, which is equals to Y2 minus Y. Now substituting these values in 1, we get M1 upon M2, that is PA upon BP is equals to M1 upon M2, which is equals to AQ is equals to X minus X1, that we got here, X minus X1, and PC is equals to X2 minus X, X2 minus X, and PQ is equals to Y minus Y1, so Y minus Y1 here, and BC is equals to Y2 minus Y. So it is equals to Y2 minus Y. So M1 upon M2 is equals to X minus X1 upon X2 minus X, which is equals to Y minus Y1 upon Y2 minus Y. So now we will take M1 upon M2 is equal to X minus X1, X2 minus X. Again M1 upon M2 is equal to Y minus Y1, Y2 minus Y, to get X and Y, that is the coordinates of the point P, X comma Y. So after taking M1 upon M2 is equal to X minus X1, X2 minus X, which we get X is equal to M1 X2. After cross multiplication we get this M1 X2 plus M2 X1, M1 plus M2. So X coordinate, to find the X coordinate we have to solve this. Similarly, if we take M1 upon M2 is equals to Y minus Y1, which is equals to Y2 upon Y2 minus Y, we get y is equals to m1 y2 plus m2 y1 upon m1 plus m2. So, if we want to find the x, we have to use this, and when we want to find y, we have to use this relation. So, this way we can find the coordinates of x and y. So, the coordinates of the point P x comma y, which divides the line segment joining the point A x1 comma y1 and B x2 comma y2 internally in the ratio m1 is to m2, is given by m1 x2 plus m2 x1 upon m1 plus m2 comma m1 y2 plus m2 y1 upon m1 plus m2. This is known as the section formula. So, we have obtained the section formula. We have to solve some example using this section formula. There are some special condition. If the ratio in which P divides AB is k is to 1, then the coordinates of the point P will be k x2 plus x1 k plus 1 comma k y2 plus y1 upon k plus 1. When the ratio is k is to 1, we have to use this formula. In special case, the midpoint of the line segment divides the line segment in the ratio 1 is to 1. Therefore, the coordinates of the midpoint P of the join of the point A x1 comma y1 and B x2 comma y2 is given by, so in place of k we have to use 1. So, 1 into x1 plus 1 into x2 upon 1 plus 1, that is ratio is 1 plus 1. So, 1 plus 1 comma 1 into y1 plus 1 into y2 upon 1 plus 1, which is equals to x1 plus x2 upon 2 and y1 plus y2 upon 2. So, this formula we have to use when the this formula we can use for the midpoint of the line segment when the ratio is 1 is to 1. Now, let us solve one example using section formula. Find the coordinates of the points which divides the line segment joining the points 4 comma minus 3 and 8 comma 5 in the ratio 3 is to 1 internally. So, here we have to find the coordinates of the point which divides the line segment joining these 2 points 4 comma minus 3 and 8 comma 5, and here the ratio, that is m1 is to m2 is 3 comma 3 is to 1. So, here let P xy be the required point. Here x1 is equals to 4, y1 is equals to minus 3, x2 is equals to 8, y2 is equal to 5 and m1 is equal to 3 and m2 is equals to 1. These are the given points. So, using the section formula, now this is the section formula that we have obtained just now. m1 x2 plus m2 x1 upon m1 plus m2 comma m1 y2 plus m2 y1 upon m1 plus m2. So, now here m1 is equals to what? m1 is equals to 3. So, here we will write 3. Then x2 is equals to 8. So, 3 into 8 plus m2 is equals to 1. So, we will write here 1. x1 is equals to 4. So, 4. Then m1 plus m2 is 3 plus 1. m1 is 3, m2 is 1. Now, y is equals to 3 into 5. 3 is the m1, that is 3. Then y2 is equals to 5. So, 3 into 5 plus m2 is equals to 1 and y1 is equals to minus 3. So, 1 into minus 3 upon 3 plus 1, that is m1 plus m2 is equals to 3 plus 1. So, now 3 8s are, it is 24, 1 4s are 4. So, 24 plus 4 it is equals to 28, 3 plus 1 is 4. So, 28 upon 4 it will be equal to 7. So, also 3 into 5 it is 15 plus 1 into minus 3 it is minus 3. So, 15 minus 3 upon 3 plus 1, that is 4. So, it is equals to 12 upon 4. So, 12 upon 4 is equals to 3. So, now we got the coordinates, that is 7, 3. So, therefore, 7, 3 is the required point. Let us take one more example. In what ratio does the point minus 4, 6 divide the line segment joining the points A minus 6, 10 and B 3, minus 8. So, here what is asked? Here the coordinates of the point is not asked, but the ratio is asked. So, we have to find the ratio. So, let minus 4, 6 divide AB internally in the ratio M1 is to M2. Using the section formula, this is the section formula, that is M1 x2 plus M2 x1 upon M1 plus M2, M1 y2 plus M2 y1 upon M1 plus M2. So that's why minus 4, 6 is equals to M1 x2. M1 we don't know, x2 we know, x2 is equals to 3. So 3 M1 minus M2 is we don't know, so we will write M2 as it is, and x1 is equals to minus 6. So 3 M1 minus 6 M2 upon M1 plus M2. Here y2 is equals to minus 8, so it is minus 8 M1 and y1 is equals to 10, so 10 M2 upon M1 plus M2. Now recall that if x comma y is equals to a comma b, then x is equal to a and y is equal to b. So that's why minus 4 is equal to this 3 M1 minus 6 M2 upon M1 plus M2, and 6 is equal to minus 8 M1 plus 10 M2 upon M1 plus M2. So therefore, minus 4 is equal to this and minus 6 is equal to this. So now we have to solve this separately. So on cross multiplication we will get minus 4 into M1 plus M2 and 3 M1 minus 6 M2. So minus 4 into M1 is minus 4 M1 minus 4 M2, which is equals to 3 M1 minus 6 M2. After solving this, we will get this, we have to take it this side, that is 3 M1, it will become minus 3 M1 here. So this will become minus 7 M1, which is equals to this 6 on this side, it will become plus 6 M2. So it will become which is equals to minus 2 M2. So that is M1 is to M2 is equal to 2 is to 7. We can also verify by taking this. So if you take minus 8 M1 plus 10 M2 upon M1 plus M2, which is equals to minus 8 M1 minus 8 M1 upon M2 plus 10 upon M1 upon M2 plus 1. This we got by dividing M2 throughout. So we have divided M2 from this. So 10 M2 upon M2, so M2 will cancel and it will remain only 10. So here M1 upon M2 and M2 upon M2 will be 1. So we get minus 8 M1 plus upon M2 plus 10 upon M1 upon M2 plus 1, which is equals to, now here we have substituted the value of M1 and M2, that is 2 and 7. M1 is equals to 2 and M2 is equal to 7. So minus 8 into 2 upon 7 plus 10 upon 2 upon 7 plus 1. So on solving this we will get 6. So that's why this is correct, that is 2 upon 7, that is M1 upon M2 is 2 upon 7 is the required ratio. Alternatively, we can also solve by using M1 upon M2 can also be written as M1 upon M2 is equals to K is to 1. Instead of M1 upon M2, we can also take it as K is to 1 Here A minus 6 comma 10, here A minus 6 comma 10 and B 3 comma minus 8. Let minus 4 comma 6 divide AB internally in the ratio k is to 1. So using the section formula, so when the ratio is k is to 1, we write the section formula like this: kx2 plus x1 upon k plus 1 comma ky2 plus y1 upon k plus 1. So therefore, we already know the coordinates of the point, that is minus 4 comma 6 is equals to, after substituting the value of this x2 and x1, we get 3k minus 6 upon k plus 1, and y2 and y1 we got minus 8k plus 10 upon k plus 1. So that is why minus 4 is equals to 3k minus 6 upon k plus 1, and 6 is equals to minus 8k plus 10 upon k plus 1. So that's why we got minus 4 is equal to 3k minus 6 and k plus 1. So now we have to cross multiply to get the value of the k. So we got minus 4 into k plus 1 is equal to minus 4k minus 4, which is equals to 3k minus 6. So when we take this 3k on this side, it will become minus 4k minus 3k. So that is equals to minus 7k, which is equals to, if you take this 4 on this side, it will become plus. So minus 6 plus 4 is equal to minus 2. So minus 7k is equals to minus 2. So k is equals to 2 upon 7. That is k is to 1 is 2 upon 7. So this is the ratio, that is 2 is to 7. So we got the ratio 2 is to 7, which divides the line segment joining the 2 points, that is A minus 6 comma 10 and B 3 comma minus 8. So you can check for the y coordinate also. So the point minus 4 comma 6 divides the line segment joining the points A minus 6 comma 10 and B 3 comma minus 8 in the ratio 2 is to 7. So students, today we learnt about the section formula and also we have solved some examples. Today we will learn how to find the area of the triangle. Now we already know the area of the triangle formula. What is the formula? Area is equals to half into base into height. So here we have the triangle ABC. We know the area of the triangle is equals to half into base into altitude. But here we don't know any altitude or the base. So how to find the area of this triangle? In 9th standard we learnt about the Heron's formula, in which we can find the area of the triangle using the sides. But here we also don't know the side, that is AB, BC and AC. So how to find then area of this triangle? So if we use that Heron's formula, then first we have to find the AB, BC and AC. And to find this AB, BC and AC, we must know the coordinates of this A, B and C. So let ABC be any triangle whose vertices are A, x1 comma y1, B, x2 comma y2 and C, x3 comma y3. So if you know these coordinates, then we can find AB, BC and AC using the distance formula. So after getting these sides AB, BC and AC using distance formula, after that we have to use the Heron's formula. So it will be a tedious work, so we have to find some easier way out. So let us see that. So draw BQ perpendicular to the x-axis, then AP perpendicular to the x-axis and CR perpendicular to the x-axis meeting at Q, P and R. So here we got trapeziums, that is ABQP is one trapezium, then ACRP is another trapezium, and BQCR is the one more trapezium. So here we got 3 trapeziums and 1 triangle. So by using that area of the trapezium, we have to find the area of this triangle ABC. So clearly ABQP is ABQP, APRC and BQRC are all trapezium. Area of the triangle ABC is equals to area of the trapezium ABQP plus area of the trapezium APRC minus area of the trapezium BQRC, that is area of this trapezium plus this trapezium APRC and minus BQRC, this trapezium. So then we will get the area of this triangle, and we know that area of the trapezium is equals to half into sum of the parallel side into distance between them. Half into sum of this parallel side into distance between them, that is QP. Here is the distance for this AB QP. So by applying this, we get area of triangle ABC is equals to half into BQ plus AP, half into BQ plus AP, sum of the parallel side, into QP, that is the distance between them, plus half into AP plus CR into PR, PR is the distance between them, and AP and CR are the parallel sides, minus half into this BQ plus CR into the distance between them, that is QR. This is QR. So on putting all the values of this, we get half into BQ is equals to here, BQ is equals to Y2, then AP is equals to Y1. So half into Y2 plus Y1, then QP is equals to X1 minus X2 plus half into AP, AP is equals to Y1 and CR plus CR is equals to Y3 into PR, PR is equals to X3 minus X1 minus half into BQ which is equals to minus half into Y2 plus Y3 and X3 minus X2 is QR. So this is equals to, on solving this we will get half into X1 into X2 Y2 minus Y3 plus X2 Y3 minus Y1 plus X3 Y1 minus Y2. This is the formula for the area of triangle. So this is that formula, half into X1 Y2 minus Y3 plus X2 Y3 minus Y1 plus Y3 Y1 minus Y2. This is the formula for area of the triangle. Let us solve one example. Find the area of a triangle whose vertices are 1, minus 1, minus 4, 6 and minus 3, 5. So let us use that formula to find the area of the triangle. So here let x1 is equals to 1, y1 is equals to minus 1, x2 is equals to minus 4, y2 is equals to 6, then x3 is equal to minus 3, y3 is equals to minus 5. So area of triangle is equals to half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So the area of the triangle formed by the vertices A 1, minus 1, B minus 4, 6 and C minus 3, 5 by using the formula above is given by. So this is equals to half into 1, x1 is equals to 1, then y2 is equals to 6, 6 minus y3, y3 is equals to minus 5 plus x2, x2 is here minus 4 into y3 minus y1, y3 is minus 5, y1 is minus 1. So minus into minus it will become plus. So minus 5 plus 1 plus x3. x3 is equal to minus 3. So, we will put here minus 3 into bracket y1 minus y2. y1 is equals to minus 1 and y2 is equals to 6. So, minus 1 minus 6. So, after solving we will get here 6 minus into minus 5, it is equals to 11. 6 plus 5 is 11. 11 into 1 is 11. Then again here minus 4 into bracket minus 5 plus 1, it is equals to minus 4. Minus 4 plus minus 4 into minus 4 is equal to minus plus 16. Then this will be minus 1 minus 6, it is equal to minus 7. Minus 7 into 3, it is 21. So, this is equals to half into 11 plus 16 plus 21. So, this is equals to 11 plus 16 plus 21, it is equals to 48. So, half into 48 is equals to 24 square units. So, therefore, the area of the triangle whose vertices are 1 comma minus 1, minus 4 comma 6 and minus 3 comma 5 is equals to 24 square units. So, let us take one more example. Find the area of a triangle formed by the points A 5 comma 2, B 4 comma 7 and C 7 comma minus 4. Let x1 is equals to 5, y1 is equals to 2, then x2 is equals to 4, y2 is equal to 7, then x3 is equal to 7 and y3 is equals to minus 4. So, this is the formula, half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. The area of the triangle formed by the vertices A 5 comma 2, B 4 comma 7 and C 7 comma 4 is given by half in area is equals to half into, we have to put all the values of this, that is x1 is equals to 5, y2 is equals to 7 plus that is minus y3 is equal to minus 4. So, it will become plus 4 plus x2 is equals to 4. So, this is 4 will come here, then y3 is equals to minus 4. So, minus 4 will come here, minus y1 is equals to 2. So, minus 2 plus x3 is equals to 7, then y1 is equals to 2, y2 is equals to 7. So, 2 minus 7. So, this will become 7 plus 4 is 11, then minus 4 minus 2 is minus 6, 2 minus 7 is minus 5. After solving this, we will get half into 5 into 11 plus 4 into minus 6 plus 7 into minus 5. So, this is equals to 5 into 11 is 55, 4 into 6 is minus 24 and 7 into 5 is minus 35. So, after solving this, we will get equal to minus 4 upon 2, which is equals to minus 2. So, now we got area of the triangle is equals to minus 2 square units. But can we write any measure in the negative? No. So, that is why the area of this triangle is 2 square units. Since area is a measure which cannot be negative, we will take the numerical value of minus 2, that is 2. Therefore, the area of the triangle is equals to 2 square units. Let us take one more example. Find the area of the triangle formed by the points P minus 1.5 comma 3, Q 6 comma minus 2 and R minus 3 comma 4. So, let x1 is equals to minus 1.5, y1 is equals to 3, then x2 is equal to 6, y2 is equals to minus 2, x3 is equals to minus 3 and y3 is equals to 4. So, same formula, area is equals to half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So, now we have to put all this value in this equation. So, the area of the triangle formed by the given point is equal to half into minus 1.5 into bracket minus 2 minus 4, that is 1.5 is x1 and y2 is equals to minus 2. So, minus 2 minus y3 is equals to 4. So, minus 2 minus 4 plus x2 is equals to 6, then y3 is equals to 4 minus y1 is equals to 3. So, 4 minus 3 plus x3 is equals to minus 3 and y1 minus y2 is y1 is 3 and y2 is minus 2. So, minus 2 and plus minus into minus it will become plus. So, 3 plus 2. So, this is equals to minus 1.5 into this will be minus 6. So, it is equals to 9. Then 6 into 4 minus 3 is 1. So, 1 into 6 is 6 and this is 5 3s are 15. So, it is minus 15 which is equals to 0. So, here we got the area of the triangle is equal to 0. Can we have the triangle of area 0 square units? No. What does this mean? If the area of the triangle is 0 square units, then its vertices will be collinear. That means all the points are in a straight line. If the area of the triangle is equal to 0 square units, that means all the points are collinear. Let us take one more example. This is the last example. Find the value of the k if the points A 2, 3, B 4, k and C 6, minus 3 are collinear. We already know in the last example that when the area of the triangle is equal to 0 square units and all the 3 points are lie in a straight line, that means they are collinear. So, here what we have to find? We have to find the area of the triangle using these 3 points. Since the given points are collinear, the area of the triangle formed by them must be 0. So, this is the formula for the area of the triangle. So, now here x1 is equals to here 2, then y2 is equals to here k. So, k plus y3 is equals to here minus 3. So, minus into minus it will become plus 3 plus x2 is equals to 4 into bracket y3 is equals to minus 3 and minus y1 is equals to 3. So, minus 3 plus x3 is equals to 6, y1 is equals to 3 minus y2 is equals to k. So, 6 into 3 minus k. So, this is equals to half into 2k plus 6, that is 2 into k is 2k, 2 into 3 is 6 minus this is 3 minus 3 is 6. So, 6 into 4 it is 24 plus 6 3s are 18 minus 6 into k is minus 6k which is equal to 0. So, that is why half into after solving this we will get minus 4k which is equal to 0. So, therefore, k is equals to 0. So, that is why we got here k is equals to 0. Let us verify our answer. Area of the triangle is equals to half into, so now we got k is equal to 0. So, we have to replace the k with 0. So, half into 2, 0 plus 3 plus 4 into minus 3 plus 6 into 3 minus 0. So, in place of k we are replacing it by 0. So, this is equals to 0 plus 3 is, it will be 3, then 3 minus 3 it will be 6, 3 minus 0 it will be 3. So, this is equals to half into 2 into 3 plus 4 into minus 6 plus 6 into 3. So, this is equals to 6 minus 24 plus 18, which is equals to 0. So, now we got area of the triangle which is equals to 0 and the value of the k is equals to 0. So, students, we learnt about the area of the triangle and we have also solved some examples. I hope you have understood this. Thank you.
Prudent Scholars, powered by Lupin Pharmaceuticals.